All right, mic check, good. So I'm Max Ceron, Max Ceron, CWB Association Welding Podcast. Today we have a really cool guest, Welding Podcast.
The show is about to begin.
Hello and welcome to another edition of the CWB Association podcast. My name is Max Ceron, and we are here with the second episode coming live from Denver here at the NASCC show. This is going to be a fantastic week, and we have a great guest here. We got Curtis Hayes from Lincoln. He is a technical sales and applications representative. All right, Curtis, how's it going?
Good. How are you?
Good. And what brings you to Denver?
Well, trade show.
Are you local or did they fly in?
Flew me in. So I'm in the Charlotte, North Carolina area, just south of the border in Fort Mill, South Carolina.
Oh, cool. And you like it? You like that area?
Absolutely love it.
She's home to you?
Mm-hmm.
We just had someone earlier today tell us that if we've never been to North Carolina, we don't know anything about the U.S. That's where to be.
You got to go.
You got to go.
Got to go.
So when I go there, what do I got to look for? Well, like, is there a food I have to try while I'm there?
Well, certainly some Carolina barbecue, right?
Okay,
So
yeah.
there's North Carolina barbecue, South Carolina barbecue, NASCAR. If you're into NASCAR,
Cars are cool.
It's a NASCAR Hall of Fame is there.
Mm-hmm.
And Charlotte is just a great place to, catch a flight, connect to an airport.
You work for Lincoln, so you basically like checked off like 2 or 3 of your favorite things from the company you work at. They sponsor NASCAR.
Mhm.
They're a part of like so much of the NASCAR technology. Like I've seen the Lincoln NASCAR in person, and then the welding and applications of robotics equipment and stuff that is used in the production of NASCAR vehicles. So
Mhm.
you must love that.
I do. I'm not a huge NASCAR guy,
Okay,
honestly,
all
but it is cool to see our stuff and it's cool to see how we can help develop the sport and give back to the sport in more ways than just giving them money.
Yeah.
Right.
Now, when we talk about Lincoln, most people when they think of Lincoln, they think of welding,
Mhm.
right? And in terms of welding machines, welding equipment, and over the last few years, Lincoln has really gotten into the education streams, development of new technologies, automation, obviously robotics for a long time. So, what is Lincoln doing here at the AI or at the NASCC show? This is not steel construction. People think of bridges, they think of structures, buildings. What's the connection? What are you guys here to present?
Yeah, the big thing for us here is going to be our larger automation systems. So things like PythonX, which is what I do, Zeman, which is a recent acquisition.
Mm-hmm.
So these are both geared towards the structural steel market. And we've got some other stuff. I mean, obviously the welding stuff is important too.
Yeah.
It probably wouldn't, the Lincoln booth wouldn't be as big as it is here if we didn't have these other larger solutions specifically geared towards structural steel.
Now, is there any partnerships that you guys have developed with associations in terms of structural steel development? That's just kind of a question pops in my head. Like the AISC is an association, we're an association, and often associations are seen as kind of the conduit to get information out into the public.
Sure.
Right. So does Lincoln have those kind of relationships like that as well?
Yeah, much like we have with CWB or American Welding Society or AISC.
Mm-hmm.
We sit on the boards. We've got people that sit on the boards. So Dwayne Miller is a big name in a lot of these circles.
Mhm.
You may have heard of him. So he's retiring.
Are you going to take his job?
No, that's outside of my scope. But things like certainly welding stuff. When it comes to like this PythonX machine, we pioneered plasma cutting holes
Mhm.
for structural, and getting that into the code. So yeah, absolutely. We play a part in that. And now you see, you walk around here, you see a lot of different cutting robots that try to do what we do.
Yeah.
But when we first started doing it, we had to put it in the code because there was no thermally cut holes allowed for structural steel. So,
And that makes a big difference when you're up, 14 stories with a mag drill on your shoulder, trying to drill holes, which sometimes is not the easiest thing to do.
Yeah.
Right. To have them pre-cut or formed at the point of
Mhm.
of production is huge, right?
Yeah.
especially when you have equipment that can automate almost the entire beam from start to finish.
Yep.
So what's some of the equipment you guys brought along here to this show? What's some of the cool stuff you guys are showcasing?
Yeah, we're definitely showcasing the PythonX stuff. We're definitely showcasing the Zeman line. So Zeman is an acquisition we just made in Austria. Zeman produces a steel beam assembler and a steel beam welder. So it's a fully automated assembly and welding system.
So when you say steel beam welding machine, it welds two steel beams together, or it's a machine to make a steel beam?
Yeah. So typically, when you're doing structural steel, you're gonna most of the structure is bolted together, right? But a beam needs to have whether it's clips or whether it's stiffeners or it's got to have stuff attached to it.
Yeah.
So the steel beam assembler will actually your beam is processed in your drill and your saw or your PythonX or whatever, and then it's presented to this machine, and then the parts that you're going to weld to it are laid up on a table. And I mean, any orientation, you just place them on a table, and a robot comes and scans all the parts that are on this table, identifies what each one is, its orientation, and checks for tolerance.
Okay.
And then it will pick up each part, place it in the beam, and another robot will come and tack it. And it can assemble the beam that way. It can do a base plate. You can assemble that, end plates, almost anything that can be attached to a beam. This machine can put together, and then you can have it welded out for you if you want to.
And then is this a rotating fixture so you can do both sides of the beam?
Yep.
And what if it comes across a part that's outside of tolerance?
Then it'll flag the operator, and the operator can either choose to continue or we can take it out and
replace it.
Yeah.
Now, I'm curious about how this works. When it scans it must have more than one scanner, right? Because if you need to get at least 3 or 2 scans, because you're going to only be able to check 2 axes at a time. So is there like multiple scanners that run across it to check the tolerances?
No, just the one. So it it's an overhead linear scanner, yeah. And it just it checks most of the parts are going to be flat.
Because I was wondering, like, what if there's an angle iron?
Yeah.
How will it know if the height's right?
Yeah, I'm not sure, because I know the angles kind of like go into like a little pocket. I'm not exactly sure how it does that.
I'm curious now. We're gonna have to Google this later.
Well, we've got the experts over there. We can go talk to them.
Daniela, can you run down to the Lincoln booth? So in your role as technical sales and application rep, what is it that you get brought to do? To discuss the equipment, to kind of run through the X's and O's of what's there?
Yeah. So the way Lincoln kind of approaches sales is really just it's bringing a solution to the table. So, someone who's looking at whether it's automation or just they come to us with a problem like, hey, material handling is really my big thing. Or, I got no floor space. I need to increase my throughput with less people and without increasing my shop space, right? Those are the problems that we
generally,
address. So, whether something like a PythonX is part of that solution is really just kind of, up to us to discover with the customer. Maybe it's something as simple as some more advanced like welding processes to help speed up the welding side of things.
And then obviously safety, because like low fume, fume extraction, all these like new parameters and designs that every manufacturer is trying to figure out, right?
Yeah. It could be as simple as, literally, we do like welding productivity training with some of our customers, and it could be as simple as having a second welding gun at the station, so that the operator, when the liner goes bad or something, they're not chasing down another liner and replacing a liner in a torch. It's just, okay, we'll just unplug that gun, plug this gun in, and then, someone from maintenance will come and pick that one up and straighten it out. Yeah.
Now, what about in terms of like yourself? What were you doing before you started working for Lincoln? What's your background?
So I was in school. So Lincoln hired me right out of college. I went to school, University of Toledo in Toledo, Ohio. I studied electrical engineering and computer science. And Lincoln's kind of funny when they approach you for an interview. They say, hey, what do you want to interview for? Engineering or sales? I'm like, that's kind of a weird question to ask. Why are you asking that?
Yeah. And what did you say?
And I said, well, that's what I answered. I said, that's really kind of a weird question. Why are you asking that? So they say, well, look, we hire engineers for our sales guys. Okay, that's interesting. Tell me more, right? And so the person on the phone, I can't even remember who it was. They just said, well, our salespeople, they generally don't live in Cleveland, Ohio. They live, wherever, and mostly the U.S. I'm a U.S. based guy, and they solve customer problems. They go into shops and they, whether it's a welding problem or a, you name it. So they kind of described the role to me a little bit, and I'm like, yeah, that actually sounds pretty good.
Pretty fun.
Because I'd done some internships at other companies. I did it too, like as a software developer.
Yeah.
Not for me.
No.
I like it, but I don't like it 8 hours a day, every day.
Too much sit down screen time.
Yes.
Yeah.
Yep.
I did my first year computer science, and it made me literally not want to look at computers for a while. And I still to this day am super geek with computers. I love computers and tech, but going to school for it and doing it for a living are two different things.
Yes.
Yeah.
Yeah.
So then you got this kind of laid out in front of you, like, look, this is the Lincoln methodology of hiring. And I got lots of good buddies that have worked at Lincoln over the years, and they really like it. Then many of them are engineers that end up doing, great sales and technical support. The problem solving of the engineering part works really good with the technology of the machines, right?
Yep.
Now, how did you like going to the Lincoln school? Because that's pretty neat too.
Yeah, no, I think a company like Lincoln who brings people in, right out of college, or it doesn't have to be right out of college. We had plenty of folks that don't come right out of school, but they bring you in and they train you for the job that you're going to be doing, right? And not just like, here's 2 weeks of training and then off
Good
you go,
luck.
right? It's 9 months of training.
Yeah.
Starting with learning how to weld.
Yeah.
Right.
Which is very, very good. Like all engineers that work in any type of conjunction with welding should have some basic welding skills.
Yes.
Because it's just to have that solid combined language, just so you even know what you're talking about. And also street cred, man. You need that street cred.
Yeah, I think the best engineers are ones that can get out on the shop floor and speak with the operators, even in our own factory, right? The guys like, that can go out and talk to someone who's operating a robot and they like know what that operator is doing. I think the operator respects that. And it's not just a guy, okay, here comes the young engineer with the clipboard, run. He's here to solve the world's problems, but doesn't know anything about what I'm doing. So yeah, absolutely. I think that's huge for an engineer,
to get that education.
Yeah. To know what it is going on the plant floor.
How did the school handle the COVID pandemic? Like they just finished putting like that huge, like it's 180 booth, like training center. Like I was there right before it finished and it was amazing even before it was done. And then like COVID hits, it's like, because I was down there for some STT training, which is, if anyone out there who's a welder or hasn't been to the Lincoln Center, I think it's called the Lincoln Center of Excellence or something like that, isn't it? Like
something like that.
Yeah. And go if you get a chance. It's really fun. Just really cool toys to play with of all kinds, but they got this massive training center now. And then I was wondering, like, the COVID must have put a real dent in those plans, but I don't know. Do you know anything about that?
I really don't, honestly.
Yeah. I thought about it.
Yeah, I know we still had training, right?
Yeah.
But I don't know what it looked like. I'm sure it was all socially distanced. And
well, it was a big enough building. You could probably still have 100 people in there at 6 feet apart.
Probably.
So in terms of, your guys' technology and related to steel construction, what we're doing here at this conference, obviously you've talked about the Python, stuff like that, but what about the welding machines themselves? Do they have a special role in the structural world?
Yeah, so I've been out of the welding side a little bit for the last couple of years, but things like our hyperfill. So that's
the 2-wire one.
2 wires out of one contact tip. We've
That's
had a lot of
fly,
success in structural steel with that. The welding automation, we've got a cobot over there. So a lot of people are certainly drawn to that because now you can. Structural steel welding is generally not the same thing over and over again. Yeah. And so stuff like a cobot is a good entry level into some automation where you can just drag the arm, put it where you want it, say start here, end here, and do that and have an operator close to the robot where there's not all this safety fencing. If the robot bumps into you,
and the dead man switches and all that stuff.
Yeah. If the robot bumps into you, it stops.
Yeah.
It doesn't throw you across the room.
And it doesn't, for people that are listening, don't understand the difference between a cobot and a robot. the robots not necessarily bigger, but generally more precise. But they have more programming involved.
Yes.
A little bit more in-depth requirements to set up and run a robot, but you have a higher level of precision. Cobots is a slightly lower level of precision, depending on what you're looking at, but much easier, much more user-friendly, and kind of more safe in an open environment. Right.
Yeah. You can bring the robot to the piece instead of bringing the piece to the fenced in, safety barricaded, robotic cell.
Like in my future mind, I see like a little trolley with like 2 seats and like a welder, like a human welder in one seat, and the cobot beside him, and they like work hand in hand. Where like he's kind of just working with the cobot, and it's like his like best welder buddy. And it's kind of Jetson-y kind of thinking, but I don't know.
That's one of the visions of cobots for sure.
I mean, and the prices of these things has gone way down, way down. Like it's unreal. Like small manufacturing shops could really think about simple automation now.
Yeah. But in general, I mean, robots, you see them making car doors and high production stuff. I mean, you've been seeing that for 30, 40 years.
Yeah.
When you bring it to something like structural steel, where it's not the same thing over and over again, robots have really struggled because they don't have a way of varying, even if all that's different is the width of the beam, it's just a little bit different. To a robot, it's a whole different program.
Yeah, it's no go.
Yeah. So things like cobots, things like our, the Siemens system, the PythonX, and those two systems are driven off of drawings, which I think is really, that's kind of the future of where these things are headed. Is how do I take a 3D model of
just
whatever I'm doing and say, here's where the welds are, go. That's where future development of robots is going to be, and it's here now. Well,
and it's the AI component. That's the part that's missing. Or I mean, shouldn't say missing. It's here, but it's still cumbersome. It's still large and requires a ton of machine capability. But it's that. I mean, the AI component's always been the part that's missing from the robots or even the cobot. It's like, if I encounter a problem, can I problem solve my way through this? Which is a hard no at this point for most robots.
Yep.
Even the attempts that have happened in the past. I've worked with some development with robots, and so like a new product that came out 15 years ago was like seam tracking. Okay, cool. Well, this is going to revolutionize everything because now it'll just follow the seam. Well, it's not that simple. It still had a ton of barriers. And then like some of the new ones will have like contour following, where it'll send ultrasonic waves, and so if the plate warps, it'll be able to follow the contour of the plate. Awesome, but still not really the solution. It has to be something much more in depth that can control a large number of variables, right?
Yep. But I think your last podcast, you were talking about, when you're under the hood and you're doing the welding, you're on the fly, torch angle, travel angle, speed, you're watching the puddle, you're adjusting a million different things at a time, and you can see where you're going, and a robot can't. Quite frankly, robots are dumb. They just do what you told them to do. And it's kind of the same like a self-driving car, right? So self-driving cars, you think, well, driving's not that hard. I mean, you and I do it all the time. We can kind of be on autopilot ourselves, but it ain't that easy for a machine, right? So once you start getting some of that machine learning AI stuff into it, things, I still think you'll probably need a drawing, but I think a lot of that stuff will be better.
Yeah.
For sure.
And like, I mean, self-driving. What if you get in an accident while you're self-driving? Whose fault is it? Like an automated car. Like if you crash your automated self-driving car 2 or 3 times, does your car have to go back to driving school? Or like,
you have your car pay the ticket?
Yeah, like really, like how does it work?
Yeah.
Or does your car have to blow into a breathalyzer if it gets caught drunk? Like I don't know. Like, I don't know.
Those are questions for somebody else.
Now, in your career, how long have you been with Lincoln now?
11 years.
Holy man, that's a long time. Like, right? So this is like your first and only job?
Yep.
Holy, you're going to be a lifer.
Yeah, probably. Probably stuck there.
They're
stuck with me, right?
Yeah. Where's your career taking you in these 11 years? Like, what was your first job?
So my first assignment. So I did the Lincoln training for 9 months. So that's in Cleveland, Ohio. So quick trip.
Go Browns.
Yep.
I'm a huge Browns fan.
Excellent. Yes. Love it. So from Cleveland, they shipped me out to South Louisiana. So I did 6 years as just a Lincoln Electric, they call us technical sales representatives.
Mm-hmm.
So a broad breadth of product knowledge, but a very small geography. So I covered Southwest Louisiana,
Mm-hmm.
a lot of piping, a lot of pressure vessels, heat exchangers, offshore stuff, a lot of round things down in South Louisiana. But I've always been drawn to automation. So I started looking for some opportunities with automation, and then opportunity came along for the cutting automation, which is the PythonX
Mm-hmm.
system. So I put in for that, and they gave it to me. And then I moved from Louisiana to Charlotte because I had a much bigger geography, but a much narrower product focus, like one product,
Yeah.
right? So as a Lincoln rep, these guys, we've got, I think, 180 of them. They've got thousands of products, every single welding consumable we make, every single welding machine we make, all of the automation we offer, right? These guys have
Electrodes,
Yeah.
everything.
I mean, safety glasses,
yeah.
hats,
Helmets,
all that stuff.
jackets.
Yeah.
Oh, man.
Every single thing.
Lanyards,
Everything.
pens.
Everything.
It's endless.
Yes. And the price, I tell you, in the few years I worked for Lincoln as a sales rep, as
Mm-hmm.
a technical sales rep, the thickness of the product catalog got a lot thicker during that time, right? Because we came out with new welding consumables, we came out with new welding machines, we bought companies.
Yeah, lots of
You know.
acquisitions there where it's really expanded the lines.
Yeah, I mean,
Yeah.
I can rattle off probably 20 acquisitions in the last 11 years
Yeah.
that I've been working for Lincoln. It's the just the complexity of the product, the complexity of the product knowledge has grown, and it's a really fun challenge. Now I just do the one thing, but that's got its own unique challenges, because you can really dig in and be an expert on the one thing, and the different types of customers that you encounter. It's been a lot of fun.
So would you say that at this point you are an expert on the Python and the Python systems?
I hate using expert, but I know enough about it to answer most questions.
Okay, so I'm curious then.
Mhm.
I have some questions. So,
Okay.
Previously, most structural work on beams or connecting structures had to be drilled,
Mhm.
right? Because of the heat affected zone and the problems with the heat on the whole, creation, and also, the ability, repeatability, dimensions, blah, blah, blah. Why was Python able, like what sets Python aside, or why were they able to kind of crack that threshold where you were only able to drill before, but now you can do it with a heat process?
Yeah, Python really did the work. And when Lincoln acquired Python, we're very particular about, especially specs, codes, that sort of thing. So we've got a whole like 85-page document that
Lays that out.
it goes into detail, not just in North America, but Japan, Australia, Europe. The big thing that Python did really was they said, we're going to make one machine to do as much as we can, right? We're not going to do we're never going to do all of it, but we're going to make one machine that's going to put the holes, it's going to do the copes, it's going to do the cut to length, it's going to do slots, it's going to do bevels, it's going to do miters, it's going to do all these things, and it's going to do it in one box, right? So what challenges do we need to overcome? Well, free edges, not really a problem. The holes were really the problem. So they set about doing, and this was before the Lincoln acquisition, but when you plasma cut, you've got kind of a natural taper to, because of the shape of the arc that comes out of the end of the torch.
Yeah, and the pressure change as it pushes through and the thickness of the material.
Yeah. So if you can identify the material thickness, the hole diameter, the amperage that you're cutting at, you can articulate that torch with a robot head and take the taper out of the part that stays, right? And so if you look at a part, especially if you get like a thick piece of steel and you cut a hole in it, decent diameter, you can really see how much taper is left in the slug.
Yeah,
that
and the
comes out
quality of
hole.
the cut as well.
Yeah. And so that's a lot of things. It's choosing the right robot. Because some robots are better at making small circles than others. That's having the software that can identify the thickness of the material and
and
all
do that
different parameters.
calculation. Yeah.
Yep. And tilt the torch ever so slightly.
Yeah, it'll be like a degree.
Yes.
Or half a degree.
It's very small. In most cases, you can't see it if you're looking
Yeah.
at the machine. Now, if you can get something really thick, you can actually see some of that head articulation,
Yeah.
which is pretty cool. But that's what they had to do in order to even approach, AISC about, hey, what about doing thermally cut holes, right?
Yeah, put this on the spec chart.
Yep. And so AISC does have a spec for it.
Yeah.
CISC has it. The governing bodies have these things, and it's about the surface roughness is really the big thing. So it's 1,000 microinches in the U.S. So develop that with AISC and then hit it and not just hit it, but I mean it's
Every
gotta
time.
it's got to be a lot better than
Mhm.
1,000 microinches, and
Yeah.
it is. It's significantly better.
So what were the changes? Like, say I go buy a plasma from my local hardware store,
Mhm.
and it's like a 200 amp plasma, which is going to be plenty for most of anything I ever need. And most beams, really, for as heavy as they are not that thick of
Mhm.
metal. It's more about how they're constructed and the type of steel. So let's say a 1/2 inch to a 1/2 inch. I got a 1/2 inch of plate at home, and at the thickest point of where I'm making my hole on the beam, I got a 1/2 inch. Why is that plasma going to differ from that plasma? Aside from the tapering and the cone of cut, that surface, finesse that you need.
Mhm.
Why won't it be able to get it?
Well, for one, it's got you attached to the end of it, right?
Yeah.
So
I'm just shaky no matter what.
go draw me, 5 1/2 inch holes, and they're all going to look different. Right?
You're on. No.
So beyond the what's holding the torch. I mean,
Yeah.
there's high definition, the high definition stuff where it uses air and oxygen, gets you a much cleaner surface, right? So that's
Okay.
part of it too,
So it has to have that oxygen air mix. It can't just be compressed air.
right? right.
Okay.
Yep.
Anything else?
That's pretty much it.
Really, just
Yeah.
a robot, and so
Robot.
basically get your dumb off of it,
Yeah.
and get some pure oxygen on there
Yep.
to elevate those temperatures, because oxygen is going to elevate the temperature
Mhm.
and create a cleaner cut. Just like why we add a little bit of oxygen to weld to create higher
Yep.
heat puddle, increase deposition rate.
Yep.
Okay, that makes sense.
Yeah. And the machine, the machine's made for, it's a high definition machine too, right? So
Yeah.
that's part of it too.
Now could you? I'm going back to the garage idea now, because I'm thinking about my plasma in my garage.
Mhm.
If I was to put in some oxygen, pure oxygen, will that just make my cuts cleaner? Or does my machine need to be special? Will I just melt my plasma head to obliteration?
Yeah. So some like air plasmas are capable of doing, a little bit of oxygen. Like, so we make some, sort of handheld / machine plasmas that can do some of that. It's hard on the consumables, and again, you're still you're still on the other end of it. Right?
Yeah, and I'm the weak.
So,
I'm the weakest link.
Exactly.
Now, in terms of what is happening in the Lincoln world,
Mhm.
There's a lot of development going on. The hyperfill blew me away. I worked for years on dual wire systems for subarc and watched them all fail. Like, they were all a gong show, expensive gong shows. And then all of a sudden, Spencer comes to my shop to tell. I don't know if you know Spencer or ever met Spencer. He's one of the sales reps up in Canada. Awesome guy. He comes, prancing into my school and being like, "Hey, check it out. We got this dual wire." And I was like, "Never gonna work." Like, it's never worked. I've never seen it work. There's arc issues because the magnetic fields and the wires. Like, you can get real technical as to why it doesn't work, and I've never seen one work.
And
it
come
was
down to Louisiana.
right. And then
Lots of multi-wire subarc systems. But continue.
Yeah, right. But over time, what happens is the wires will pull towards each other, right? Or away from each other, unless you use ACDC. And
Bingo.
then, once you go to ACDC, but then you lose on deposition rate, unless it's a big game you got to play, right? So he's telling me that this is the same machine, same, stuff. You just got to change out the gun, put in this extra doohickey, and then change out the rollers and tip, and you're good to go. I was like, and so he brought it to the school, and I was like, all right, let's see this thing go. And what does the orientation of the wire matter? He's like, it doesn't. And I was like, okay, now you're selling me pixie dust. Like, this just doesn't make sense in my head. And then I ran it. It ran beautifully.
Mhm.
And then I realized that it's because the wires create a bridge.
Yes.
The bridge, and the subarcs don't bridge. That would be bad.
Mhm.
So that it was like, oh, now stuff like that is mind blowing, which I think was pretty mind blowing. Is there lots of that stuff coming down the pipe? Like, can you give us a teaser? Is there some other cool, awesome invention that's coming around the corner from Lincoln?
That's a good question. I don't know. I just know that there are people that are in the dungeon in the basement and
24/7
dreaming this stuff up.
Yeah.
And they're like, well, what if we did? What if we put 2 wires out of one contact tip? I don't know. Let's try that. And I just I'm sure it's more sophisticated than we got a mad scientist down there who's doing stuff. Maybe not.
Maybe not. No, I kind of like that idea.
Yeah.
That's a very romantic thought. I'd love to see that.
Yeah. Well, and a company like Lincoln who they want that stuff, right? If Lincoln was a part of a larger, conglomerate
Yeah.
organization that's, just after the bottom line, I don't know that we'd have those liberties. Right? I mean, we spend a lot on R&D. Last I've heard, we spend more on R&D than all of our competition combined. Because that's just, we want the technology, we want the best. And, I don't think you can get that unless you have control over your own destiny like we do.
Now, are all the Python systems, are they all headquartered here or produced in North America? Or because I know Lincoln has, for a long time, Lincoln was very much like, we are just North American. Even the manufacturing plant in Canada was like, okay, this is a little iffy. We're moving into Canada. It's a, kind of outside the norm of not being, made in the U.S. for all the aluminum products. And now there's offshore. Now there's actual Lincoln products that are produced overseas. And I know that they're great. Like, I mean, I think the 5Ps are made overseas. Maybe some of the consumables. There's some things that are done.
That stuff's still made in Cleveland.
Is it? Okay.
But we do make, so our strategy, again, best I know, is that we produce like consumables. If we're making 5P in China, we're making it for China. We're not bringing it here.
And right? I think that's what I heard is like, I mean, it's just more about the local distribution of product. And you say like Lincoln's not a big conglomerate, but I think for the average person out there, they would look at Lincoln as a giant conglomerate because it's a huge company.
Sure.
It's probably one of the biggest.
It's a big company. It's, when you look at like, some of these like massive companies, we're a $3-4 billion company.
Yeah.
So it's big, but it's not, $100 billion company like some of these,
like Amazon,
like an Amazon. Yeah. I mean, and even Amazon's kind of like their own boss, it's not like,
they don't get owned by somebody.
Yeah.
So what is, now I'm just dreaming. What's is there like an owner at Lincoln? Is there like one president of all of Lincoln?
Yeah, we got a president, CEO. I mean, it's a publicly traded company, so there's a gajillion shareholders that own the company, myself included.
Yeah. Oh, do you got shares?
Yeah.
Well, or is it part of the work thing?
It's just part of the 401k.
Oh,
thing.
okay. I don't know what a 401k is. That's
like
American
it's
thing.
American retirement dealio.
So you get $401,000. Is that how it works?
Yeah, that's totally. I mean, we don't have no free healthcare or anything like that, but we got $401,000. No, it's the tax code.
Okay.
Yeah.
I'm like, wow, that sounds awesome. How do I get one?
Yeah. It's just the American retirement
plan,
most common retirement plan for companies.
Cool. So going forward, 11 years in the company now.
Mm-hmm.
You got 11 years in. Where do you see yourself going? What's your plan in terms of the products you're working with now? Do you want to see that to go to some larger scale, or are you kind of seeing where you can go in the company and do other stuff?
Yeah. So automation is still my thing. I love telling machines what to do and having them do my work for me. That's always been sort of my draw to that stuff. I don't really get to use my super technical stuff, but that's fine. I take care of that. I got like a little laser at home. I got a couple 3D printers at home. That takes care of that for me.
Yeah.
So automation for sure. Probably some kind of sales leadership is really what my next step, my next vision would be.
Yeah.
At the company, and we'll see where that goes.
Cool. And how is it to move in? So like you kind of told your story you got hired, you had these options. Now for the listeners, there's someone say coming out of welding school and they want to work at Lincoln.
Mm-hmm.
How do you approach that? Do you just apply? Like you don't have to be in Cleveland to work at Lincoln, obviously, but is there opportunities that get posted? What's the career paths within Lincoln like?
Yeah, I mean, there's the website's got job postings.
Yeah.
I'm sure we're hiring all the time. Cleveland is where we make most of our stuff here in the U.S.
Mm-hmm.
We've got sites in Chattanooga, Tennessee. They do robots there. We got Pythons are made in Ontario.
Mm-hmm.
So if you're around a place where Lincoln has a
A
site,
footprint, yeah.
we probably need welders, right?
Yeah.
We need, just like everybody else, right?
And what about welders that want to get into sales? Is that something that Lincoln would look at, or are they looking more for engineers?
Yeah, we certainly have welders who've jumped into sales. Yeah, definitely.
That's interesting. What's your kind of group look like? Like, how many people do you work with in your Python world?
There's 5 of us.
And do you guys all do the same stuff, or do you all have to like develop different things?
Yeah, no, we all do the same thing. We just cover different parts of North America.
So basically, the entire country split between 5.
Yep.
And what about Canada?
Yeah, same group.
Yeah.
So we cover U.S. and Canada. The 5
So
of
who's
us.
the Canadian guy?
There's a couple. We've got Carrie in. She's in Ontario, but kind of like right between, like right on the border of Ontario and Quebec.
Mm-hmm.
So she covers that sort of area. We've got Ron. He covers out west, and then he covers kind of like the Midwest U.S. I think those are the only 2 we have.
Okay.
They're both located in Canada.
Okay, we'll have to
cover
track
parts of
them
Canada.
down and find
Yeah.
these Canadian people.
Yeah.
What's some of the hobbies that you kind of do with Lincoln? I know Lincoln's got lots of cool stuff. You say you got lasers,
Mhm.
you got 3D printers. So what are the things that you do in your nerd time?
Yeah, that's pretty much it. I do.
So you make something in your 3D printer and then you
Mhm.
use your laser to make things on it, or
Yeah, I haven't
I'm just
really,
curious now.
Yeah, I haven't figured out a way to integrate both of them into a project. Although that's probably that's. I mean, I just bought the laser. I don't know, a couple months ago, so I'm getting my feet into that. But it seemed like that would complement a couple of 3D printers. I've built. I built one 3D printer. The other one, I there's not a lot of parts left of what it used to be. We'll put it that way.
I've been trying to get into that. Has Lincoln gotten into the 3D printing game, like the 3D metal printing?
Yeah, big time. So we actually have a display over at our booth, and then I think at the entrance there's a big like AISC logo or something like that.
Oh yeah, I did see that. Like it's
Yeah.
on a black carpet thing. Yeah.
Yeah.
That was in one?
So we 3D print large metal parts. So we're not messing around with these like little powder things. We got big things.
So it's like a MIG on a robot.
Yeah.
Just doing it like dot by dot or like running stringers or
Yeah, line by line. So we've got I don't know all the details about what we got, but we've got it's CAD to path, right? So kind of the same thing we've been talking about. So there's a model that drives the robot path.
Mhm.
We've got our own slicing software, which is what takes a model and cuts it up into layers. I guess I understand it can slice in multiple different planes, and so we can rotate the part. And so if you went and saw the models that we have on the floor, you'll see lines in this direction, and then you'll see lines in this direction.
And it actually
in
rotates,
multiple
yeah.
different planes. But it's pretty cool. I mean, we've got like a pipe that we 3D printed over there. We got like a beam we 3D printed. At some of these shows, like a Fab Tech, we'll bring like a 3D printed truck frame rail. It's pretty cool what we can, a big propeller.
Yeah.
There's stuff, and a lot of that stuff you can't make. I mean, you
Yeah.
cannot make.
Well, you'd have to cast it, right?
Yeah.
Like
But it's hollow.
Yeah.
You can't make that
No.
without doing it's. The fancy word is additive.
Yeah.
And then we acquired a machining company that has multi-axis machining capabilities for our additive business, so that we can machine the critical, the critical geometries. But I guess it's a pretty. Again, I don't know a lot about that side of
Yeah.
the business, but I guess it's pretty successful for stuff that you probably had to cast or forge,
And it would be so heavy.
and heavy and long lead times. We can just
Yeah.
print it, and then we can just machine.
Machine to finish
Yeah.
on it. Yeah.
So like tooling, dies, that's the thing. Like stamping dies, I think
Mm-hmm.
that's one thing that they talk about a lot. Where we can 3D print that and just machine the surfaces down.
I actually was just looking at trying to get a custom stamp die made.
Yeah.
And it was an incredibly complex process. And I was like, really? I thought you could just like get like an ingot of steel and machine it to what I need. It's like, well, no, then the hardnesses are wrong. It's like, okay, well, can't we figure that out? Like, why is this so hard? But I guess it is. Now, what kind of equipment you guys got over there in total? You got the Python. You're talking about the 3D printed stuff. What other cool stuff you got over in your booth? Because you guys got a big booth over there.
Yeah, we do. Most of our stuff's virtual this year because we just didn't really know what the situation was going to look like, and so we have to plan this stuff out ahead of time. But the things we're showcasing, definitely Python, Zeman. We got the Cobot. We actually have a physical Cobot over there. We've got a Torchmate tables. Torchmate does like small light industrial.
Yeah, like the 4x4 tables and 4x8. Yeah.
So we've got a Torchmate 5100, which is a 5x10 model.
Okay.
It's got the Lincoln Fine Line plasma machine on it. So that's the power source and the torch.
Are those new? I don't think I've heard of them.
They're fairly new.
Yeah.
A couple years old. I
Okay.
think we launched them at FabTech in 20.
It would have been 2019 because
yeah.
you weren't at the last one last year.
Right. Yeah. So, but we've been putting that on Pythons for a couple years now, and
Awesome.
really good success. And again, it's kind of part of the Lincoln way of owning your own way. So we make the machines in Cleveland, Ohio. We print our own printed circuit boards, which like nobody does that.
Yeah, I just had a conversation with somebody yesterday about the struggle of not being able to create circuit boards, and the companies that can make their own circuit boards right now have a huge advantage because it's so hard to get anything overseas now.
Yep. We machine all the parts for the torch in South Carolina. We mold our own plastics. I mean, it's Lincoln's pretty cool when they want to take control over something, they'll take control over it.
When they get in their head that they want to make it, they'll do it right from top to bottom.
Yep.
Yeah. Well, that's cool. And I see that with the way they operate with their staff, kind of with their consumables. Like, not all products are always great. Like in a school, you're running through, hundreds of kilograms of electrodes and you'll get a bad box, and it happens. And it's like a big deal when you call the Lincoln guy and send him a picture and be like, hey man, these rods are out of concentricity. And they're like, stop the presses, get the label picture. I'll be down there. Here's free 5K box. Oh my God, we're going to send this off. And usually that's not, most companies will be like, yeah, whatever, send it back. We'll give you another one. But they'll like send you like a report after, like what happened.
Like an autopsy.
Yeah, it's like like forensic files on these rods that you're like, whatever. Normally you just throw them away, but you actually they want to know because they want to help fix their process. Right. They're not so much worried about you being. I mean, I shouldn't say that. They are worried about you being unhappy about the product, but you could fix that by just replacing it. Just here's a new one. See you later.
Right.
But they actually want to like fix what happened in that situation. Right.
Yeah.
Now, what's going on with Lincoln after hours? Because everyone knows Lincoln has the best parties. Are you not allowed to tell me right now on the air?
No. I got nothing.
Come on. I guess it's top secret. We're not invited in Yellow.
I think the FabTech is where the after party happens. At NASCC, it's not really
not that type of crowd. I haven't seen as many young people here as we do at FabTech.
Yeah. You want to know about the party? Petting House has got the party.
Yeah,
they're the ones that do the NASCC party.
Okay, good to know. We'll have to go chum up with them and see what's going on.
For sure.
We got some insider information. We'll be like, hey, Curtis from Lincoln said to come on over here, and you guys know what's going on. All right, Curtis. For we're coming up at the end of the podcast here. In terms of like the audience that we have, if they are either looking at getting Lincoln products or maybe getting into like the Lincoln stream of work, what would be some advice you'd give them for, like, let's say you're in college or you're coming out of high school and you like the way Lincoln does business. What would be a way to contact Lincoln or to kind of approach that whole idea?
Yeah, that's a good question. I think it depends on where you're at. If you know a local Lincoln guy, I mean, we got local Lincoln guys and gals everywhere. I will say our HR folks, when you apply on the website, I think they're really good about actually responding and getting back to you, and so I'd say really the website would be a good place to start.
Yeah.
Certainly if you know somebody or you can get contact info for one of the local Lincoln folks, that doesn't hurt. We do around Ohio and some other spots we'll do like career fairs.
Okay.
Like that's where they recruited me out of a career fair at the University of Toledo. So if you're in one of the schools, I know we do a lot with do Ohio State. We do like Missouri S&T. I think the guys out there are really big into recruiting there. So there's different places where we'll recruit. And when I've done recruiting, like I did some recruiting at LSU, we did interviews like on the spot, you know.
Okay.
So if someone came up and we had a good conversation, we'd say, hey, we want to interview you. And we'd set a date for the interview, and we'd interview you the next day or the next week or whatever. We do internships, sales and engineering internships.
So pretty involved.
Yeah.
And what about if you're a company looking to, like, say, not able to come to these conferences like this, or they're too far away, or maybe just not quite big enough for the investment, but they're interested in some of the machines? They'll be able to see, obviously, everything you have here online.
Mm-hmm.
You know, how do they get to maybe check these out? You know, is there places around North America where Lincoln has machines set up to give demonstrations? How does it work in terms of, like, you know, maybe accessing some of the more, you know, I guess, distinct machinery you guys have?
Yeah, the best way, I think, is get in touch with the local Lincoln person.
Yeah.
So we have a lot of people, like I said, scattered throughout the country, in U.S. and Canada. If it's a hyperfill, something like that, I mean, chances are the office might have one floating around that they can bring to your site.
Mm-hmm.
Always would recommend coming to visit us in Cleveland, Ohio.
Yeah.
It's a great, just to really get a feel for the company. You know, our plant, our main plant there is a 1 million square feet.
Yeah.
It's huge.
And you guys have that really cool, like, museum thing at the front there with, like, the history, and that one, what is it, like 2,000 amp generator welding machine. It's like, what is that?
Yeah, with the big Frankenstein switches.
Yeah. It's like, what is that thing? What am I welding? The moon?
Yeah.
Like, Jesus.
Welding broken hearts in the crack of dawn.
Oh, there we go. Holy, there we go. I don't have. I lost my heart. My heart is black and shriveled, and it's just dross now, unweldable. All right, man. Well, this has been a really great interview. I hope you've had fun.
I did.
Is there any shout outs you want to send out to anybody that might be listening, or anything you want to promote?
Yeah, definitely shout out to my Python customers for sure. I appreciate your business. I think in general, anyone who uses Lincoln product, you know, certainly appreciate your business. That's what keeps us running.
Mm-hmm.
And I appreciate Lincoln Electric for having a great environment to have a you know, long-term career at. A lot of folks my age don't stick around with a company this long, and I think it's a pretty strong testament to how Lincoln is managed.
Yeah, like I'm my age, and I've never made it 11 years in a company. So yeah, you're doing awesome. There must be something awesome there.
Yeah.
So I really appreciate it. And for all the people that are listening, Curtis, he's in North Carolina.
Mm-hmm.
If you guys want to reach out to him, and of course, like he said, there's Lincoln reps all over the place. And this has been really informative. Every time, I think you're the second or third Lincoln person I've had on the show, and I always learn something new. There's always a wide range of products coming out. It's always a cool time. So I really appreciate it, and I'm sure we'll be partying all week. So
Alrighty.
All right, man. We'll have a great time.
Thanks for having me on the show.
We hope you enjoyed the show.